Hello everyone, this is Tiger. Today let's take a look at the 2021 JMC paper, and we'll be doing the questions from question 1 to question 15. So let's take a look at what questions we have today. Alright, so for the first one, simple question, numbers and operations, of course. And it's going to be just about basic calculations or like basic operations. So 123 take away 456 adding 789. What we can do is that we can swap the order of the calculation because we know that these are commutative, right? For addition and subtraction, they are commutative. So I can take away 456 from 789 first. So 789 take away 456 is equal to 333. Adding that on top of 123, and we will get the answer 456. So A is the answer. The second question. So this one is numbers and calculations again. And it will be about numbers and operations. It will be about the unit conversions. So what we need to do is to convert these pounds into pence. So we need to be careful of that. 20 pounds is equal to 2,000 pence, and 50 pounds is equal to 5,000 pence. Right? So 2,000 pence all in 5p coins is going to be 2,000 divided by 5. That's 400 coins. 5,000 divided by 2 is the number of coins we have in 2p. That's 2,500. Adding together, that's going to be 2,900. So the answer is E for the second question. And then for the third one, again, a numbers and operations question. So it's about bitmas this time. So we need to multiply 2 and 3 first. We need to multiply 2 and 3 first. And then 4 divided by 5 as well. So 2 times 3 is equal to 6. 4 divided by 5, that's equal to 4/5, which is 0.8. So I'm having 1 take away 8 adding 1 take away 6 adding 0.8, which is minus 5 adding 0.8. And it is not minus 5.8, it is minus 4.2. So the answer is going to be A. All right. And then the fourth question, how many of these are multiples of 11? So it will be about divisibility. So it's about number theory, divisibility. Of course, if you don't know the divisibility of 11, that's just a numbers and operations question. You can just divide them one by one to see. But if you know the divisibility of 11, you can see that it's just going to be finding the difference between the odd digits, like the, for example, like the ones digit, the hundredths digit, and such, and so on. So you're skipping a digit when you're taking the numbers, and you're just trying to look for the sum of each skipping digit and look at their difference. If that difference is 0 or any other multiples of 11, then it is divisible by 11. So the first one is divisible by 11. The second one, well, 1 and 6 adds up to 7. 5 is just 5. So that is not a multiple of 11 because the difference is 2. That's not a multiple of 11. And then that's 5. That's 5. So yes. That's 9. That's 9. So yes. That's 3. That's 3. So yes. So we have 4 of them altogether. Okay. And for question 5. It says that when I have walked 20% of the way to school, I have 1,200 meters more to walk. Then, when I have 20% of the walk remaining. So what does it mean? It is pretty wordy, this question. So clearly it's a word problem and it's going to be on percentage. So what it means is actually that after you have walked 20% of the distance, you still have 1,200 meters more than 20% of the walk remaining. What it means is that this section, 1,200 meters, is 1 take away 20%, take away 20%, which is going to be 60%. So we know that 1,200 meters is 60% of the walk, which means that the total distance is equal to 1,200 divided by 60%, which is 1,200 divided by 60 over 100, that is times 100 over 60. And we can simplify 60 and 1,200 to see that's going to be 20 times 100, which is 2,000 meters. Okay, so the answer is going to be E for this one. And then for question 6, again, it's a numbers and operations question. We got quite a lot of numbers and operations here. And it will be on fractions. So the first step is definitely just trying to write all these calculations of fractions inside the brackets as a single fraction, single improper fraction. So 2 take away 1/2, that's going to be 3 over 2. 3 take away 1/3, that's going to be 8 over 3. 4 take away 1/4, that's going to be 15 over 4. All right, so that's the calculation simplified. And then we can cross out the 3's because they cancels out. Divided by 2, 8 is going to become a 4, and 4 cancels out with a 4. So all we have remaining is going to be 15. And B is the answer for this question. All right. So far these are easy questions. And question 7 is slightly trickier. So this is a question on angles. First of all, we can see that this is an isosceles triangle, which means that the two base angles are going to be the same, right? So each of them is going to be 180 degrees, take away the top angle 36 degrees, divided by 2, and that's going to be 72 degrees each. Because the angle sum of triangle is 180, right? So that's where 180 comes from. And then starting from the second one, we can see that this is again an isosceles triangle with TQ equals QR. So what I can do is that I know these two base angles are the same, and these two base angles add up to the 72 degrees right here, because these are the two non-adjacent interior angles for 72 degrees, which is the exterior angle. So these two add up to 72, which means that each of them is 72 degrees divided by 2, that is 36 degrees. So this is also 36 degrees. Probably I'm just gonna write it a little bit smaller such that you know which angle I'm talking about. And then for the last one, we use the same method to see that each of these are the same, because the last triangle is also isosceles, and each base angle is going to be half of 36 degrees. Well, again, because the interior angles that are non-adjacent adds up to the exterior angle. So each of them is 36 degrees divided by 2, which is 18 degrees. So as I said, this is a very important theorem. Please remember that. So the angle PTS is going to be 36 degrees adding 36 degrees, adding 18 degrees, which is going to be 90 degrees. All right. So C is the answer to this question. And moving on to question 8. Again, this is a numbers and operations question. And it will be on bitmas again. So, first of all, we're calculating 4 take away 5. such that the equation will become 1 take away in brackets 2 take away in brackets 3 take away 4 take away 5 is minus 1, so in brackets minus 1. That's it. And if 3 is taking away minus 1, we know that's equal to 3 adding 1, right? So that's going to be 4. So we have 1 take away in brackets 2 take away 4. And what is 2 take away 4? That's equal to 1 take away minus 2, which is 1 adding 2, and that's going to be 3. So the answer is E for 3. All right. Oh, I forgot to put my head down. And for the next question, oh, I still need to hide my head. The next question is a miscellany question on cross numbers. So if you were with me in the JMC short-term course, you must know how to solve this problem. So for cross numbers, we start from where we have the most limited options, right? We can see that for the 4 clues, they are a square, a square, a square, and an odd square. That's definitely the most limited one, right? So we're starting from the odd square. 3 across can be 25 or 49 or 81, right? These are the 3 options we have. But then when you're trying to fill these 3 numbers in there, you can see that if it is 25, 1 down cannot be a square because no squares end with a 2. The same goes for 81. No squares end with an 8 right there. Yeah? So it means that the only possibility, because 1 down has to be a square, so it means 3 across has to be 49, such that 1 down ends with a 4. So as a result, the value of x should be 9. Okay? That's why. So I don't care what are the other boxes, because it didn't really say it. It didn't really mention it in the question. All I need to know is that x is 9, right? That is what it's asking for. And then for question 10, I would say that this is the half area model in geometry. So let's say it's the half model. But basically, we don't actually need to use a lot of that knowledge from the half model because it is kind of intuitive. So I just need to cut it into 2 parts because I know that these are the midpoints of a side of the square, right? So it means that I have 2 rectangles on both sides. Does it make sense? And for the shaded part, it's going to be a quarter of the rectangle because it has the same length as the rectangle. And for this triangle, the height is going to be half the width of the triangle, right? So it means that the area of the triangle is equal to 1/2 of the width times length divided by 2. That's the base times the height divided by 2, right? So it's going to be a quarter of length times width, which is a quarter the area of this rectangle. So it works the same way on the other side. That's a quarter of the right-hand side triangle. So if they're combined together, it's just going to be a quarter of the left and a quarter of the right, which is a quarter of the whole thing. So it's going to be a quarter. That's the answer to this question. Okay? And if you really want to prove that it's a quarter, we know that these two triangles, so A and this shaded half, is going to add up to 1/2 using the half model. And also because we are taking the diagonals, so the opposite ones must be the same. That's why it's a quarter. All right, 1/2 over 1/2, that's a quarter. And question 11, it says that a particular prism has 10 faces. How many edges does it have? So I would say it belongs to 3D geometry because I don't know which part of 3D geometry does it belong to. Probably recognizing 3D shapes. So yeah, as long as you know what a prism is, you will be able to find out the answer. So a prism is a shape which the top and bottom are the same, and then they are connected with some rectangular faces, right? So if it has 10 faces, it means that there will be 2 faces on top and on the bottom, and 8 faces surrounding it, right? 8 faces on the sides. So it has to be an octagonal prism, which means that for the top edges, there are 8 of them. For the side edges, there are 8 of them. And for the base edges, there will be 8 of them as well. So, is an octagonal prism. 1 top face, 1 bottom face, and 8 side faces. So the number of edges is going to be 3 times 8, which is 24. Okay? I don't know how to explain it any further, to be fair. That's just what a prism is, isn't it? Okay? And for question 12, so this one is finding the unit value, or you can also use ratio to solve it. But basically, these two are very similar. So word problems, and it belongs to finding the unit value. So, not value. So it says that Jaslyn answers 4 questions every 30 seconds. So it means that in 30 seconds, she can answer 4 questions, which means that she can do 7.5 seconds for a question. So it takes her 7.5 seconds per question. And Ella answers 5 questions every 40 seconds. So for every question, it's going to be 8 seconds. Now, it says that Jaslyn took exactly 1 hour to answer a large set of questions. How many minutes more than Jaslyn did Ella take to answer the same set of questions? So if Jaslyn took exactly 1 hour, it means that the number of questions is going to be, well, since we want the answer in minutes, so we might want to convert hours into minutes first. And then, it means that the number of minutes that Ella is taking is going to be 8 over 7.5 times 60 minutes. Because 7.5 seconds is, well, you can say that the ratio between their speeds is 7.5 to 8. Yeah? So you can just divide it by 7.5 and multiply 8, even though the units doesn't match, but since I'm expressing it as a fraction, it means that it is a ratio, basically. So I'm dividing the time Jaslyn takes by the speed of Jaslyn and multiplying it by the speed of Ella, such that what it has, like what we have here, is going to be the time for Ella. So it's going to be 16 over 15 if you are just trying to make both of them integers by multiplying 2 on both sides. So we have 60 times 16 over 15, which is going to cancel out to 1 and 4. So 4 times 16 is 64 minutes. Now finally, how many minutes more? It's going to be 64, take away 60, which is 4 minutes more. Okay, so the answer is D for this question. Well, if you're not really understanding this method, it's okay. You can just then convert 60 minutes into seconds. which is 3,600 seconds, and then divide it by 7.5, you will find out the number of questions. Multiplying it by 8, you will know how many seconds it takes for Ella to finish it, and then dividing it by 60 to convert it back to minutes. All right, that's just a little bit more clumsy in terms of the calculation, but you will get the same answer eventually. So for question 13, again, it's something that we have been talking about in the short-term course. Well, I didn't deliberately chose these topics. You need to trust me with that because I have forgotten what 2021 paper was about. It's just a coincidence that after these lessons we have exactly these questions to solve. So it's going to be about angles, and we can use the overall thinking in this question. We can see that the marked angles together with these 5 angles is going to be 5 triangles, right? So let's call them A, B, C, D, and E for these 5 angles. And now I can see that the marked angles, adding A, adding B, adding C, adding D, adding E, is going to be the angle sum of 5 triangles. That is 5 times 180 degrees. Now, how do I find A, B, C, D, and E? We know that by the vertically opposite angles, this is A, this is B, this is C, this is D, and this is E. And all of them adds up to 360 degrees because they are angles at a point, right? So we know that 2 times of A, B, C, D, and E is 360 degrees, such that A, B, C, D, and E once each is 180 degrees. So I can replace this by 180 degrees. Now, the marked angles adding 180 degrees is equal to 900 degrees, right? So the marked angles is equal to 900 degrees, take away 180. That's going to be 720 degrees. So the answer is going to be B right there. Okay? So we are just thinking about all these individual angles as a whole, and we are not trying to calculate individual ones. We're not trying to calculate each of them. And for question 14, to be fair, it is a little bit hard to classify it. I think it belongs to the number machines in numbers and operations, or like defining new operations. So what it says is that when I'm dividing a 3-digit number by 9 and subtracting 9 from the answer, I still get a 3-digit integer. So you can just try to imagine if you're dividing a 3-digit positive integer by 9 and it's still ending with a 3-digit integer, the large integer that I'm starting with must be starting with a 9, right? So it must be 900 something. And furthermore, after you divide it by 9, you're subtracting another 9 from it, which means that there can't be many positive integers that you can end with, right? So the number of different positive integers you can start with will be equal to the number of different positive integers you could have ended with. So if I'm just swapping everything around, it means that a 3-digit number at 9 times 9 is still a 3-digit number. So we can start trying from the smallest one. 100 adding 9 is 109 times 9, that is 981. 101 adding 9, that's 110 times 9 is 990, which is already quite big. 102 add 9, that's 111, times 9 is 999, which can't be any bigger. Otherwise, it won't be a 3-digit number anymore, right? So we have 3 different positive integers to begin with. 981, 990, or 999. Okay? And then the last problem is going to be a word problem on money. But to be fair, it's not just any other money problems. It says that Alex has a pile of 2p coins. She swapped exactly half of them for the same number of 10p coins, which means that, say, the number of 10p coins is x now. So she will have the same number of 2p coins now, right? So let x be the number of 2p coins and of 10p coins. All right. So what we can see is that 2x adding 10x is going to be 420 pence. Remember, you need to keep the units aligning. So it means that 12x is 420. So I'm dividing 420 by 12 to find x. X is going to be 35. So now it means that Alex has 2x, which is 35 times 2, which is 70 coins. Initially, they are all 2p coins, which means that the total initially is going to be 70 times 2, which is 140p, and that's equal to £1.40. All right. So that's the answer for the last question. I would say that this paper is not really hard, but then the questions are pretty weird. Like, this is actually one of the weirdest year of the questions that I've ever seen. If you know what I mean, after doing so many years of past papers. Well, so that's just it for today. Thank you everyone for listening, and I will see you again on Thursday. All right. If there's any questions, just please do let me know. Bye bye. See you next time.